what our plan for this morning is to dive straight into the OpenQuake files for the 2015 hazard model to show you briefly what the different files are, how they're structured. And then we've simplified the models a bit to be able to work on our laptops for the exercises for today. So we'll do a couple of examples with probabilistic seismic hazard analysis, then maybe break for coffee, and then Catalina will more forward into probabilistic seismic risk using the Monte Carlo event-based approach. So I don't have any presentation because I think Michael covered almost everything that I wanted to say about introduction to BSHA, introduction to the models, etc. So I can give you one of the questions was, can you look at these source model files or look at these maps in GIS software? And the answer is it's quite easy to do. In OpenQuake, it's not documented, but there's a tool to convert your source model files into GIS shape files or GeoPackages. And so in the QGIS project that we've provided you, we've done that for you already. This is the damage calculation from yesterday. Let me turn that off and zoom out a bit. So in the group called data, there's the top group of layers is the NBCC 2015 hazard model. And we've loaded in the seismic sources and also the hazard maps, the calculated hazard maps using OpenQuake. So if I switch that on, you should be able to see the different seismic source groups. You can see these are different zonations that Michael was describing. The historical zonation is the tectonic regionalization, and I guess this is the hybrid model. So you can look at each of them in turn. So it's pretty easy to convert your XML input files for OpenQuake, the source model files, into shape files that you can visualize in QGIS or even ArcGIS. It's the same format. Does that answer your question? Was that one of your questions? Right. So these are the different source models. Let me turn that off. What we've done for today's exercise is you also have the full files, but we have clipped the source model files to an area just around the Quebec City Windsor corridor. So it's this area plus a buffer zone of around 300 kilometers. So even these, if you look at these layers, if you look at the attributes, many of those should be in here. So the minimum magnitude, the maximum magnitude. I guess, are you talking about these? As long as these are included in your source model files, many of them get copied into the shape files as well. Yeah, so for today's exercises, we've clipped these models to a smaller area so that you're not just trying to compute the hazard from all of these sources for your area of interest. We've also loaded in the pre-computed hazard maps covering all of Canada. So if you switch on the seismic hazard maps there, we have 6 of these maps just for PGA at 2 different probabilities of exceedance, and spectral acceleration at 0.2 seconds and 1 second. So you can take a look at those if you're interested.
And they're for the set site class or for the total history?
This is for a VS30 value of 760 meters per second. This is when we computed this as part of the global maps. So all of them used some range of VS30 between 760 and 800 meters per second. Because you were involved in this discussion when you were trying to convert the maps from 450 to 760.